Okay, so your job with this is to take the ordered pairs that you clearly see on these graphs. I want you to find the equation for the green line. I want you to find the equation of the blue line. And is there some interesting fact that you can discover through that process? Okay, I'll give you a few minutes to do that. All right, green equation. What was the equation you got for the green guy? Brian.
I got y equals 1/4 x plus 5/2.
I'm going to say we were close, but not quite right. Okay.
At least we were close.
Oh, hold on. You might be right. Hold on. Brain. Say it again.
1/4 y equals 1/4 x plus 5/2.
Okay. I don't know where, again, I apologize, my brain. Yes, that is actually the right equation. We get y equals 1/4 x plus 5/2. Okay, how about the blue? Yeah, well, let's just stick with fractions. 2.5 is the same, though. Okay. All right, how about the blue guy? And here's the reason why I say that is because if we don't have a denominator that goes evenly into the numerator, then we get a repeater, and that just looks weird in an equation. Okay? Patrick, what'd you get for the blue guy?
Y equals 1/4 x minus 9/4.
I didn't get that. Oh, hold on. Maybe I did get that. Hold on. Let's try that again.
Y equals 1/4 x minus 9/4.
And now I do agree with that. I'm telling you, I should not be allowed to do math when I've had less than 7 hours of sleep. So the answer is y equals 1/4 x minus 9/4. Okay? We had our two ordered pairs. The interesting thing when I put the blue equation into slope-intercept form, I used the point 1, -2. And I ended up getting y plus 2. We got to watch out because the formula itself has negatives in it. So if my coordinate also has a negative, the double negatives makes a positive. So I think that's where I know I made my first mistake. Tristan.
Can you work for the second equation?
The blue one?
Yeah.
So our 2 points were -3, -3. And -1, or 1, -2. So first I'm going to figure out slope. Connect and subtract, and that makes it a plus on top, so I get this is a -3, over a -4, and that gives me a positive 1/4. So then I'm going to take, it doesn't matter which pair, I'm going to take the one that has the 1, -2. So y take away the y coordinate of -2 equals 1/4 times the quantity x minus the x coordinate. So then that's y plus 2. So I get y plus 2 equals 1/4 x minus 1/4. So I have to subtract 2 from both sides, which I'm going to rewrite as -8/4. And because I've run out of room, I'll put it over here. And I get y equals 1/4 x minus -1, and -8 is -9/4. Okay? So again, all I had to do is rename that whole number into a fraction that had 4 in the denominator. Okay, so let's go back. Let's look at these two equations. And what are some things that you can tell me or you observed or something that you could conjecture based on this experience? Allison.
They have the same slope.
Oh.
Just different line.
So we have same slope. Different y-intercepts. Okay? What else can you tell from this? Brian?
The lines are parallel.
The lines are parallel. So basically what you've just discovered is what you're going to work on homework tonight. If you get the idea that slope, if you ever are told that you have parallel lines, they have to have the same slope. If you want to prove you have lines that are parallel, you need to prove that they have the same slope. So let's quickly write down our notes. So we'll go to the next page. That is still part of the notes, so let's go back to the whiteboard. And your oops, feel like I'm angry when I write red. So your objective is to understand properties of parallel lines. Okay. So basically, you guys told me that parallel lines, a basic definition is two lines that never intersect. So when you guys were, I was telling you my story about skiing and French fries, your French fries, if they cross, you can kill yourself. So you got to make sure that your French fries, your skis, stay parallel so that you can go down the hill. But if you have them parallel and go directly down the hill, you're going to speed like a devil out of control. So you have to be cautious when you're doing that parallel lines with your skis. So two lines that never intersect, and then you guys, just from that little exercise, came up with they have the same slopes. Oh, that's not what I wanted to write. That's what I wanted to write. Same slopes. Oops, we'll go a different color. They had different y-intercepts. And did we say anything else? No, that's pretty much it. Those are the two key components. So, to prove lines are parallel, solve each equation into slope-intercept form. If it's not already, identify each slope if slope 1 equals slope 2, parallel lines. If slope 1 does not equal slope 2, not parallel lines. You can't assume it's any other kind of line. You just know that they're not parallel. Okay, so that's pretty cool. And then, so how might it show up? You actually have already done problems using this information back on 28 through 31. Remember how it said, have an equation that has the same slope as this guy and has the same y-intercept as this guy. Well, all of those that said has the same slope as this line was saying, I want you to write a line that's parallel to this line. So that's all that you're going to do. So you're going to have some on the 31 to 34 where they're going to say, I want you to write an equation that has the same slope as this equation, that's parallel to this equation, and passes through this point. Okay? So good luck with that. It'll be fun. It'll be easy.